Hey there, I'm Henry Gilliland.
And I'm Philip Yarbrough. In this video, I will be peppering this guy with questions about a specific topic of his choosing. So Henry, what would you like to talk about today?
I know. How about we talk about servo motors?
Excellent! So I hear a lot about them. What is a servo motor?
Well, I think we better start with the word servo, which is short for the word servo mechanism.
Okay, what's that?
So a servo mechanism is just any device that has closed loop control, which means there's a control device like a PLC or a VFD, and it sends out control signals to some kind of electromechanical device like a motor, for example. To be a servo mechanism, what's being controlled must also send feedback to the controller. This feedback allows the controller to fine-tune movements and adjust for errors as well.
So it's kind of like how my body moves. My brain tells my hand to pick up the cup. My eyes and my nerves in my hand give feedback to where the cup is, and then I pick it up and drink.
Oh, yeah, exactly. The PLC is like your brain, and the motor is like your arm, and then the encoder would be like your eyes.
Wait, encoder?
Oh, an encoder is a feedback device. So it's an electromechanical device that uses optical sensors that send signals back to the PLC and drive. The signals tell the control system where the motor shaft actually is, and that way it can compare the actual position to the commanded position.
Okay, cool. So I understand the word servo now, and I know what a motor is. So is the encoder the only thing that makes the difference between a motor and a servo motor?
Well, not exactly. Most modern motors use an electromagnetic principle called induction in order to move a specially designed rotor around. That's what turns the shaft of the motor. However, servo motors are a little bit different. Instead of using induction, they have permanent magnet rotors to create the magnetic field.
Okay, can I see that?
Sure. Having a permanent magnet rotor means that servos generally have a stronger magnetic field. This gives the controller greater control over the motor. This also means that servos can produce a lot more torque in a smaller package than a standard induction motor. So the outer part is the windings of the motor. So that creates a rotating magnetic field, which turns the shaft of the motor. And then the rotor has little magnets inside. They're the little things with the humps. Do you see that?
Yeah.
Little things with the humps. That's the rotor, and those are permanent magnets inside there.
Spin this? No, you can't.
Well, you
It's
can.
really strong.
So you can see how.
Oh, I see. Can you pull it out?
No, because it's attached to the back.
Attached to the encoder.
Right. Yeah, exactly.
So
the shaft is attached all the way through the.
So the encoder can tell what this end is telling what this end is doing.
Correct.
So that this little guy can tell whatever is doing it.
Yeah, so that the drive and the PLC know exactly where that shaft is.
So these servos, they're pretty small, but how do they compare to normal motors?
Well, so as I said, they have permanent magnet rotors, and because of that, you can pack more power in a smaller package. So as an example, a 1/2 horsepower induction motor is probably about yay big. This is a 1/2 horsepower servo motor.
Oh, that's a big difference.
Yes, and a permanent magnet rotor design, along with the encoder that's built into the back of every servo motor, is usually why servos are more expensive than a comparable AC induction motor.
Okay, I think I got it. Servo motors have encoders, which give feedback, and they have a permanent magnet on the rotor that gives better control and power in a more compact device. So this is why they use them in robots and like very fine control complex systems.
Yes, exactly.
Well, thanks, Henry. Is there any other places I can find these videos online?
There sure are. you can visit ES&E TV and check out our library of technical and informational videos. And make sure to subscribe too, because we update with new videos regularly.
That's a good idea. I'll do just that. Thanks so much for talking about servo motors. I learned a lot.
The pleasure was all mine.